Hello everyone. This video covers participation number 3 for Math 130 for the summer section or summer session. Alright, so here for question number 1, we need the following properties for the logs. Remember, property 1 says the following: the log of A times B becomes log of A plus log of B. The second property says that the log of A over B is equals to log of A minus log of B. And the third property says that log of A to the K is equals to K log of A. Okay. You should memorize these properties if you're going to take pre-calculus or calculus later or even higher math classes. These properties are very useful. For question number 1, we're going to use these 3 properties. So let's start with part A. Part A is asking you to find log of Q plus R. Now here, you should just think of all of this as just a specific, just one number. Like you could say this is A and this is B. So therefore, in part A, by property number 3, this becomes 2 log of Q plus R. But you know what log of Q plus R is. It's here. It's given to you. It's telling you that it's 6. So therefore the answer to this is 12. That's it. Now here, if you factor this, remember that Q squared minus R squared is the same thing as Q minus R times Q plus R. Right, so now this is property number 1. This is a product. So by property number 1, this becomes log of Q minus R plus log of Q plus R. But you know what this is and what this is because it's given. So therefore this will be 2 plus 6 and the answer is 8. Okay. Part C, if we factor this part, this will be Q minus R squared. So now this will be just like part A. The 2 goes in front by property number 3 again. And this is log of Q minus R. But log of Q minus R is equals to 2. So this is just 2 times 2, which is equals to 4. And that's it. Now part D, by property number 2, is equals to log of Q plus R minus log of Q minus R. So this is equals to 6 minus 2, which is 4. That's it. All right, number 2 is asking you to find the inverse, and technically you can do this just in 3 steps. So step 1, just change y for our f of x for y. And step 2, wherever you see an x, put a y, and wherever you see a y, put an x. So therefore this means x is equals to 7y plus 2. And then step 3 is the one that actually requires some work and is solve for y. So it doesn't matter how the question looks, you can always use these steps. So from here, if we solve for y, you're going to have x minus 2 is equals to 7y, which means that y is equals to x minus 2 over 7. So therefore, f inverse will be whatever you get from step 3. And that's it. Alright, so the rest will be the same. So step 1, y is equals to this. Step 2, x is equals to y plus 5. Remember, in step 2, x is replaced by y and y is replaced by x. And then step 3, solve for y. Well, how do we solve for y? Square both sides. Okay, so you square this one, square this one. And then you solve for y. Y is going to be x squared minus 5. So therefore, f inverse is just a result from step 3. And I guess you could call this a step 4 if you want to, but it's not really needed. Okay. Then we do the exact same thing for part C. So step 1, y equals to x cubed minus 7. Step 2, x equals to y cubed minus 7. Then step 3, solve for y. So you're going to have y cubed is equals to x plus 7. Or y is equals to the cube root of x plus 7. So therefore, the inverse is equals to the cube root of x plus 7. And that's it. All right. Part D is the same process, but part D is a special case because we are doing a lot with logs and exponents. But we do the same steps. So step 1, y is equals to log of kx. Then step 2, you're gonna have x equals to log of ky. Now to solve for y, you have to change from log to the exponent. Remember, you look for the base. The base is k, so remember, solve for y. So that means k to the x is going to be equals to y. So that implies the inverse of a log is just an exponential function. So it will be k to the x. In question number 3, it's asking you to find the composition. And in general, so remember, in general, f composition g, which is the same thing as just of f of g, is not equals to g of f, which is g composition with f. So in general, this is not true. And by that I mean if you switch the order of the functions in a composition, they're not gonna be the same. Okay? But there is an exception to the rule, and the exception is this: the f composition with the inverse, if the inverse exists, is not only equal to the composition of the inverse with the function, but this is always equals to x. So this is a very special result. Okay. So again, in general, if you switch these two, you don't get the same answer. But if you do this with the inverse of each other, it is the answer. And not only that, the answer is always x. So therefore here, it doesn't really matter which function is, the answer will be just 4. And the answer here, it will also be 4. Now, it's asking you specifically to use 2b. And just to check that this is the case, in 2b, for 2b, the answer, so it's actually it should be for 2a and 2b. But in 2b, let's just do that one. In 2b, f of x was equals to x plus 5, and the inverse was x squared minus 5. All right, so therefore, if you wanted to compute this, you will need to find f of 4 first. And f of 4 will be the square root of 4 plus 5, which is the square root of 9, which is 3. And then you will have to find f inverse of 3. And f inverse of 3 will be 3 squared minus 5, which is 9 minus 5, which is 4. Okay? So this is the whole point of this problem number 3. That if these two are the inverse of each other, the answer is always going to be this, regardless of what function you have. So therefore, there was no need to go through all of this. I just did this to show you that you will get 4. And actually, it doesn't matter what function this is. Now, that's not the case if this was not the inverse. If you would have a function that looked like this, like f of g of 4, then you will have to compute this first, and whatever you get, you have to plug it in here. And this will not be equals to g of f of 4. That will not be the case. This is only true for inverse functions. All right, so let's go to the last problem. To solve this equation, you square both sides. And the whole point of doing that is that the square will cancel the radical, so you end up with just x plus 5. In the other side, you're going to have x squared minus 2x plus 1, y, because you just had to do FOIL or the distributive property here. And then you say this equals to 0, so this will be x squared minus 3x minus 4. Factor, so this is x minus 4 times x plus 1. So therefore the solutions, or the possible solutions, are 4 and negative 1. Okay, so these are the possible solutions. Why did I say possible? Because you still have to check. All right, so let's check first x equals to 4. So the question is, if you plug in 4 for x, is this equals to 4 minus 1? Or is the square root of 9 is equals to 3? And the answer is yes, obviously. So the first one worked. What about the second one? If x is equals to negative 1. So the square root of negative 1 plus 5 is equals to negative 1 minus 1. Or is the square root of 4 is equals to negative 2? So that's the question. Now the square root of 4 is 2, so 2 clearly is not equals to negative 2. So that means this one doesn't work. So the only solution then is 4 and the second one doesn't work. And that's it.